AI researchers and companies have recently begun to develop increasingly agentic AI systems, systems that adaptively pursue complex goals using reasoning and with limited direct supervision. For example, a user could ask an agentic personal assistant to help me bake a good chocolate cake tonight, and the system would respond by figuring out the ingredients needed, finding vendors to buy ingredients, and having the ingredients delivered to their doorstep along with a printed recipe. Agentic AI systems are distinct from more limited AI systems, like image generation or question-answering language models, because they are capable of a wide range of actions and are reliable enough that, in certain defined circumstances, a reasonable user could trust to effectively and autonomously act on complex goals on their behalf. This trend towards agency may both substantially expand the helpful uses of AI systems and introduce a range of new technical and social challenges. Agentic AI systems could dramatically increase users' abilities to get more done in their lives with less effort. This could involve completing tasks beyond the user's skill sets, like specialized coding. Agentic systems could also benefit users by enabling them to partially or fully offload tasks that they already know how to do, meaning the tasks can get done more cheaply, quickly, and at greater scale. So long as these benefits exceed the cost of setting up and safely operating an agentic system, agentic systems can be a substantial boon for individuals and society. In this paper, we will primarily focus on agentic systems with language models at their core, including multimodal models, as these have driven recent progress. Society will only be able to harness the full benefits of agentic AI systems if it can make them safe by mitigating their failures, vulnerabilities, and abuses. This motivates our overarching question: what practices could be adopted to prevent these failures, vulnerabilities, and abuses, and where in the life cycle of creating and using agents are they best implemented? There are often many different stages at which harm could have been prevented. For example, consider a hypothetical agentic AI assistant whose user, not based in Japan, directs it to purchase supplies for baking a Japanese cheesecake. Instead of purchasing supplies locally, the agent purchases an expensive plane ticket to Japan, which the user only notices when it is too late to refund. In this hypothetical scenario, several parties could have prevented this outcome. The model developer could have improved the system's reliability and user alignment so that it wouldn't have made this mistake. The system deployer could have disabled the agent from taking action without explicit approval. The user could have simply never agreed to delegate purchasing authority to an AI system that was commonly known to not be fully reliable. The airline company could have even instituted policies or technologies that required affirmative human consent for purchases. Given that multiple parties could have taken steps to mitigate the damages, every party can arguably cast blame on the other, and in the worst case, a party can be held responsible even when they could not have reasonably prevented the outcome. A key goal of allocating accountability for harms from agentic AI systems should be to create incentives to reduce the likelihood and severity of such harms as efficiently as possible. In order to make sure that someone is incentivized to take the necessary measures, it is important that at least one human entity is accountable for every uncompensated direct harm caused by an agentic AI system. Other scholarship has proposed more radical or bespoke methods for achieving accountability, such as legal personhood for agents coupled with mandatory insurance or targeted regulatory regimes. These all appear to address the same problem. In order to create incentives to reduce or eliminate harms from agentic AI systems, society needs to agree on baseline best practices that prudent model developers, system deployers, and users are expected to follow. Given such a baseline, when an agentic AI system causes harm, we can identify which parties deviated from these best practices in a way that failed to prevent the harm. In this white paper, we lay out several practices that different actors can implement to mitigate the risk of harm from agentic AI systems, which could serve as building blocks for a set of agreed baseline best practices. We also highlight the many areas where operationalizing these practices may be difficult, especially where there could be trade-offs among safety, usability, privacy, and cost. AI developers cannot answer these questions alone, nor should they, and we are eager for further research and guidance from the wider world. In Section 2, we define agentic AI systems and the human parties in the agentic AI lifecycle. In Section 3, we briefly describe the potential benefits of agentic systems. In Section 4, we provide an initial 7 practices that could be part of a set of agreed best practices for parties in the agent lifecycle and highlight open questions. Finally, in Section 5, we consider more indirect impacts from the introduction of AI agents that may not be addressable by a focus on individual harms. We hope that the best practices we outline can serve as building blocks for a society-wide discussion about how to best structure accountability for risks from agentic AI systems. For example, they may inform discussion around what regulation of AI agent development might look like, or how parties structure contracts regarding agents, e.g., insurance for harms caused by agents, terms of use regarding agents, or how courts could think of various actors' standards of care. Given the nascent state of agents and their associated scholarship, we do not yet have strong recommendations on how accountability ought to be structured, and would like to see a more robust public discussion of possible options. We hope that this paper will help catalyze such conversations without anchoring or biasing them too strongly in any particular direction.